Good morning, welcome to new lecture. Today we will look at to see how we can find displacement or deflection in trusses using virtual work method. If we have one truss, for example, subjected to different load, external load. For example, point A, B, C, D, E, F, G. For example, I want to find deflection at point F or deformation in vertical direction at point F using virtual work method. First, I will find the internal force for these members because of this external load. Then I will remove all external load and I will apply unit load in the location of interest. That location we want to find deflection. Here, for example, in this example, point F, and because we want to find deflection at point F in vertical direction, we apply unit load at vertical deflection. Then according to the virtual work method, the virtual force times or virtual load times the real deformation, for example here deformation at point F, is equal to summation of, here n is the number of the members, summation of, for each member, internal force because of the virtual load times internal force under real load times the length of member divided by EA of that member. Here you see this term and this term. These are real deformation. And this force and this force, they are virtual load. This is virtual load. For example, here we are applying at point F. This is internal forces because of this virtual load. Let's solve example. And in this example, we will find deflection because of the real load, and even we have fabrication error. Fabrication error sometimes, whenever we are fabricating members, it can be a little bit shorter or longer, and that will produce internal forces and deformation. Let's see if we have that scenario, how we can solve this problem using virtual work method. We have this truss A, B, C, D, E, F, G, H, this is our truss, and supports here we have one roller support, here we have pin support. This truss is subjected to external load 10 kips, 20 kips, 30 kips, and the length for each of these is 12 feet. and the height of truss it is 9 feet. Using the virtual work method, determine the vertical deflection at point G. So we want to find vertical deflection at point G. Cross-sectional area for all members, it is 2 inches squared. Young modulus for all members, it is 29,000 KSI. These are our external load. On the other hand, due to fabrication errors, the member AB, initially they fabricate 0.4 inch longer, member FG 0.6 inch longer, and member HE 0.3 shorter. Negative means shorter, positive means longer. So these are fabrication errors we have in these members. We want to consider the effect of fabrication error in the vertical deflection of point G as well. So we have external load, we have fabrication error. These are the cross-sectional area, Young modulus, and the dimension of truss. We want to see how much point G will deform in the vertical direction. First, we will find internal forces in all these members because of these external loads. So, we have external loads, we will find internal force in all truss members because of these external loads. That is, you can use joint method, because we want to find all of them. Joint method is easier. First you will find reaction, you can find reaction. This will be 35 kips, this will be 25 kips. Then using joint method, we can find all internal forces in these members. If you find internal forces in the members, AB, let's say right here, AB, you can double check, you will see I'm right. Force in the AB will be 33.33. It will be compression, so negative, or you can put C, means compression. Force BC will be 33.33, again negative, or compression force. CD will be 46.66 compression. DE will be 46.66 compression. Force in member AF will be 41.67 tension. Force in FG will be 53.33 tension, or positive. Force in GH will be 53.33 tension. Force in member HE will be 58.33 tension. Force in member BF will be 10 compression. Force in member FC will be 25 compression. Force in member DH will be 30 compression. Force in member CG will be 0, we know it is 0 member, and force in member CH, it is 8.33 compression. And some of these, it is very easy to figure out. There is no need to solve it here. This force, it is 0, because this is 0 member. 10 will transfer here. So BF, you see BF should be 10 compression, because apply compression. DH 30 compression. Others you can find using joint method. So first you will find all internal forces using joint method under real load. After finding those, then you will remove all external loads. So now you will find all internal forces in all members under real external forces. After you finding this, then you will remove all external forces and you will apply unit load at point of interest. Here point of interest is node or joint G. You will apply 1 kips. Again you will find internal forces in all members using joint method. So using joint method you will find all internal forces in these members. If you put here 1, these are 1 over 2 kips, half kips, 1 over 2 kips, and you will find all internal forces. This time, if I want to write, I can write FAB will be 0.67 compression, FBC 0.67 compression, FCD 0.67 compression, FDE will be 0.67 compression, AF will be 0.83 tension, force at member FG will be 1.33 tension, force in member GH will be 1.33 tension, force in member HE will be 0.83 tension. Force in member BF will be 0, force in member FC will be 0.83 compression, force in member CG will be 1 tension, force in member CH will be 0.83 compression, force in member DH will be 0. So you apply unit load at point of interest, and again you will find all internal forces in all members. Then you will create this table. You will create this table. This table, it is big table. I should remove everything. You have the picture now. So then you will remove, you will create this table. First column, it is member name. Then the internal force in truss member under virtual load. The unit, it is kips. We will show with lowercase n. The axial force in all truss member under real load, again unit kips. The length of truss member, EA for that truss member, and in this column n, the internal force because of virtual load times capital N, the internal force under real loads times length over EA. This is last column. So let's look at here. The member, if I list the members, it will be AB, BC, CE, EE, AF, BF, CF, FG, CG, CH, GH, DH, and HE. Then internal axial force when you apply high virtual load, you will write for each member in the second column. It will be compression negative, tension positive, 0.67, negative 0.67, negative 0.67, negative 0.67, 0.83, 0, negative 0.83, 1.33, 1, negative 0.83, 1.33, 0, 0.83. Then you will write axial force under real load in the third column. It will be negative 33.33, negative 33.33, negative 46.66, negative 46.66, 41.67, negative 10, negative 25, 53.33, 0, negative 8.33, 53.33, negative 30, 58.33. Then you will write the length for each member. You will calculate the length for each member, 48 inch, 48, 48, 48, 60, 36, 60, 48, 36, 60, 48, 36, 60. Then you will calculate EA. E times A for all members, it is the same number, it will be 58,000. In some example can be different, but in this example for all members it is the same number. Now, in this column, you will multiply this column to this column to this column, and you will divide it by this column. So, you will find these numbers. It will be 0.0184, 0.0184, 0.0257, 0.0257, 0.0359, 0, 0.0216, 0.0589, 0, 0.0072, 0.0589, 0, 0.0503. If you add all these, summation of these total, it will be equal to 0.3209 inch. So, the deflection at point G, because of external load, it is equal to 0.3209 inch. Let's look at the fabrication error in those members. Again, you will list the members. this column, you will write the list of members. You have fabrication error AB, FG, HE. Here you will write the force under virtual load at point G, negative 0.67, 1.33, 0.83. Here you will write fabrication error or change in length, positive 0.4, positive 0.6, negative 0.3. Then you will multiply this column to this column. You will get negative 0.268, 0.798, and negative 0.249. Then you will add these. It will be 0.281. This is the deflection at point G because of the fabrication errors in these members. So total deflection at point G will be deflection because of the fabrication error plus deflection because of the external load. If you add together, the total deflection at point G will be 0.602 inch, and because it is positive and because we apply virtual load downward, positive means this deflection downward, and we will find total deflection. Let's look at another example. Here we don't have external load, but we have temperature change. To see how we can calculate deflection in trusses whenever we have temperature change in some members. For example, you have this truss. A, B, C, D, E, 4 meter, 3 meter, 3 meter. Truss members AD and DE. Truss members AD and DE increase in temperature 40 degrees Celsius. So change of temperature in A, D and DE is 40 degrees Celsius. Member CE decrease temperature 30 degrees. So this is positive. Member CE decrease temperature 30 degrees Celsius. In addition, member BE, this member, is fabricated, fabrication error, for BE is negative 0.5 centimeter. So B is fabricated 0.5 centimeter shorter. A cross-sectional area for all members, it is 25 centimeter square. E Young modulus, it is 210 gigapascal. Thermal expansion coefficient, it is 12 times 10 to the power of negative 6 per degree Celsius. Find the vertical displacement of point B. So let's one more time, I will read the problem statement, then we will solve it. Truss members AD and DE increase in temperature 40 degrees Celsius. This. Member CE decrease in temperature 30 degrees Celsius. In addition, member BE is fabricated 0.5 centimeter shorter. Find the vertical displacement of point B. if we have expansion in AD and DE and contraction in CE, what will happen? This truss will deform something like this. Something like this. Point C will move to point C prime and point B will move to point B prime. It will go up. We want to find that deformation. Again, first we will find a change in length of these members. Let's say create table. We will list the members. Member AD, AB, BD, DE, BE, BC, CE. Then thermal expansion coefficient times 10 to the power of negative 6. For all of them it is the same number, so 12, 12, 12, 12, 12, 12, 12. Then temperature change, degrees Celsius. Here we have 40. No temperature change, no temperature change. This is 40, 0, 0, negative 30. Fabrication error, delta fabrication, centimeter I put here. Here is 0, 0, 0, 0. This is negative 0.5. 0, 0. Length of members in meter 5, 3, 4, 3, 5, 3, 4. Then we should add one more column. Here we will apply because we want to find deflection at point B, we will apply unit load at point B. So we will apply unit load at point B here. You can apply downward or you can apply upward. Both will work. So both will work. Apply downward or upward. Here I applied upward. Let's see. Here I apply upward, but you can apply downward. Then you will find internal force for all these members under this virtual load 1. And you will create another column. I don't have space over there. I should remove these. I will create another column. This is internal force in all members. Because of that, unit load. It will be 0.625 minus 0.375, negative 0.5, 0.375, negative 0.625, 0, negative 5. Then you will multiply all these together. Alpha delta TL, you will multiply alpha, you will multiply n, this column, to the alpha delta TL. So, and you will calculate the summation for that. So summation from I equal to the 1 to n, this column, alpha delta T L. So you will multiply this column to this column to this column to this column, alpha delta T L times n. N is internal force in truss member because of that virtual load. Because we have fabrication error plus summation of this column n multiplied to the fabrication error column delta fabrication. It will give us the deflection at point B in vertical direction. If we do that, if you multiply all these and add together, you will get delta B in vertical direction. It will be 0.444 centimeter and it will be upward. Because I apply unit load upward, this answer positive means I'm right. The deflection will be upward. If you apply the unit load at point B downward, in that case you will get negative answer. Negative answer means you will understand the deformation, it is not downward, it is upward, and you can sense the direction. So first you will multiply this column to the alpha delta TL, you will add together answer plus you will multiply this column to this column and you will add together, you will get total deflection at point B. Thank you so much for watching this lecture. See you next session. Bye.